Suppose that mn, capital M, and capital N are integers such that the distance from the point mn to root 2, root 3 is equal to the distance from capital M, capital N to the point root 2, root 3. Okay. So we're given that these are integers, and we're told that the distance from mn to this point, root 2, root 3, is equal to the distance from the corresponding capital letter point. Okay, so this is going to use a result from the previous part of this problem. If we just, let's first start by squaring both sides and then just write out what this is equal to. So we have m minus root 2 squared plus n minus root 3 squared is equal to something similar here. And if we expand, okay, so we get a bunch of cancellation everywhere. M squared plus n squared minus 2 root 2m minus 2 root 3n is equal to m squared plus n squared minus 2 root 2m minus 2 root 3n. Let's put everything, how do I want to rewrite this? Okay, so the way I'm going to write this is so that it's in the same form as a result in a previous problem. So if I look at this, I see that this is an integer multiple of root 2. This here is an integer, and this is an integer multiple of root 3. And so what this says is that all of the integer coefficients here have to be 0. That's a result from a previous problem, previous part of this problem, in fact. And so this tells us that m is equal to little m and n is equal to little n, because this has to be equal to 0. That only happens when capital M and little m are equal. Similarly here. Okay, so that's just using the previous result that I had gone over before. Yeah, it's pretty nice to see how the previous result can be used directly here, because of course if you tried to work this out without knowing the previous result, you might not realize that something like this is essentially impossible unless both sides are equal to 0. But as I explained in a previous video, it's because of the root 2 and root 3 being, they're both irrational and one can never be written as a multiple of the other. Anyway, nice problem. Thanks for watching.